the problem that we're tackling at FTSY is matching people to shoes that they love, fit them well and look good. At the moment, mainly the fit them well part. So the start of that is measuring people's feet to be able to know what size they are. And the way we think about it, instead of being a size 8 or size 9, which is just one number, is that your foot's a three-dimensional object that's unique, and you need to know that full three-dimensional shape to be able to really understand someone's feet and get them the right shoes. So we want to revolutionize the concept of shoe size to the FTSY shoe size. So our measure system that's already working, and you can grab this from the North American Apple app stores, is you get the workflow is that you get the app on your phone and you use our app to take photos of your feet like this, looking down in a kind of orbital, from orbital viewpoints around your foot. And then we upload those photos to a server, and there's some number crunching magic that goes on, and out of it comes these fitted meshes for your feet. So there's a 3D point cloud. That's not an image. That's a rendering of a 3D point cloud. You can see in a minute. And then we've fitted this mesh. So the way we fit that mesh is that we've got a 3D morphable model of human feet. So this model has parameters that can describe all the shapes of human feet. And it's a 3D mesh. And so here's some examples of our kind of shape components or shape dimensions. One is scale. So, if this is going in one direction, you get a big foot, and another direction, you get a small foot. These are just the same thing seen from two different angles. And it's interesting that it's not just a matter of scaling the mesh. The shape of the little feet is different from the big feet because, little feet are baby, like children's feet, and they're sort of more pudgy. Another important component is this kind of pronation or arch component. So see, at one extreme you get a high arch, and another extreme you get this flat foot. Apparently as you get older, the muscle under your foot gets a bit slack, and your foot flattens out and your ankle rolls in. So this was all learned from data. We didn't impose this. This is machine learning, number crunching, and this is what comes out from the population. And of course, width. Everybody would know that foot width is important. So we've got skinny feet and wide feet described by our model. Excuse me. So we've scanned lots of people, and so we've got a lot of data now, which is quite useful. So, and it's not just images. We've got all the intermediate things that we computed from that in our process. So we've actually got, that's one of our competitive advantages, is now we've got this data that we can use to do even better things. So this is just an example of the kind of information we've got. From one set of images, we've got all the camera positions in 3D for where the phone was when it took the camera, the fitted models, so where their feet were, the credit cards. So we use a credit card sized card to get scale. So we know where that is in 3D. We know all the toe locations. So the only thing we haven't modeled at the moment is the legs. So they're kind of unknown to us at the moment. So, just as an example of what you can do with that, this is a kind of a basic augmented reality thing where you can render the fitted model back into the 2D images that you took. So to get that point cloud we saw earlier, it's doing a process called structure from motion and multi-view stereo. So it's kind of triangulating lots and lots of features in all those images, like thousands of features. And you get all these 3D points. And then, there's some card finding that goes on in the images, and they get triangulated and so on. So something we want to do soon is using deep learning to find the card as well, and then we should be able to do that without needing the paper. Yeah, so you could re-render or back project those the model back into the images, and you also get 2D masks then of the feet where the foot pixels are in the images with the detail of the toes. But it's not a complete augmented reality solution yet because, as I said, we don't model where the legs are at the moment. So that means we don't have the information to be able to block out this part of the rendered model because so it doesn't look right yet. But we're not trying to do augmented reality right now. That was just an idea. So what else? What can you do with all this data? So what we've been doing lately is training deep neural networks to do things to kind of understand where the feet are. To give an example, so foot presence. So like in the ImageNet example, we can just ask the question, are there feet in the image or not? Just yes or no. So here's an example of a phone app where you can see when it's looking at my feet, not red, and when it's not looking at feet, it's red. So you can see that works pretty fast on a phone as well. So another thing that we're doing is pose estimation. So remember I said we take pictures like in a circle around your feet. It's helpful to know just from the image where you are on that circle, like a clock face, which we call the pose or the azimuth. And so we've got a neural network that the input is an image and the output is the pose, like it's shown here. Also foot segmentation. So we want to know actually specifically where the feet are in the image. So with our foot segmentation network, we can take an image and then have a mask of where the feet are. Show you that again. I don't know if you can see from there, but that is up my feet. We also use that as a filter so that we want people to be taking pictures the way they need to be taking them. So yeah, I'll explain that better. So I've got an example here of what we call the FTSY magic wand. So one of the challenges for us as a startup was that we've got this system that we can measure feet, but it kind of takes expert knowledge to be able to take the right pictures. They're going to be high quality pictures, focused on the feet, good lighting, and specific angles, or not specific angles, but a good range of angles right around the feet. So we found that, training people to do this or having some sort of training video, it's just too hard. It's an unnatural movement to get your phone and do this. People are not used to it at all. They're used to doing this. So what we set out to do is to put like the smarts on the phone to do that automatically. So it's like having an intelligent assistant on the phone that can really do that process for you, but just telling you where to put the phone. So I've got an example here of sort of a desktop prototype of that, but this is actually in beta on the iPhone at the moment. So you'll probably see that tomorrow if you get your feet measured by us tomorrow. So here's an example. You can see you got the video, and this is showing that the pose is being estimated just from the image. So on the phone, we actually combined the inertial sensors on the phone, and the fact that it's not grayed out means it's detected that there are feet, and then we've got segmentation, and here we've just re-rendered some generic feet at that location as a sort of guide, augmented reality guide. And as it's going around, no one's pushing any buttons or anything, but the system is just taking photographs from all the different angles. You see that they adjust a little bit, and that's because we have some criteria for image quality, and as we go, we replace old images with better images. And that was done on a webcam, but on the phone, we're actually setting the focus and the exposure to make sure that we image the foot pixels better. So from that, we get high quality images and we get better point clouds, better fitting.